This is Algebra 2, a little more practice with exponential growth and decay. All right, so on this worksheet, we are going to be talking about different ways that the exponential function grows. Now, we're used to growing it every year, every month, every whatever. So there are two ways to do these. There's the fast way and the short way. You can do these like Newton's law of cooling. The general formula would be A equals A0 e to the kt plus BO. Now you can do this to find K like we did on the Newton's law of cooling thing and use this formula. It'll work. It takes a little while to do it. But there is another way of doing it, thinking about how the half-life works or whatever growth or decay works. So let's take a look at a couple examples and see if there's a little easier way of doing this. Okay, for number one, the half-life of carbon-14 is known to be 5720 years. If 300 grams of carbon-14 are stored for 1200 years, how many grams will remain? Okay, so what we have to take into account normally when we do growth, exponential growth, it's A times B raised to the T plus whatever we happen to have changing, plus C. Okay, now the problem is, it says the half-life is 5,720 years and it's stored for 1200. Well, that's not a multiple of 5720. So we have to figure out how many grams will remain. So thinking about the half-life, we're starting with 300. If you are doing a half-life, what is your multiplier every time? You're going to take half of it every time. So your multiplier is going to be 0.5. All right, now the multiplier for that is 0.5 every 5,720 years. So that's technically for 1 year out of 5,720 would be for the 1 year. And then we want to raise that to how many times we want to do it would be 1,200. Okay, now when you do power to a power with the exponents, what do you do with the exponents? You multiply them. So what this will actually come out to be is 300 times 0.5 to the 1200 over 5720. Okay, so when you are doing this, you're saying, what do you want to use out of the total number of years? All right, so all we have to do is put this in our calculator, and you get 300 times 0.5 raised to the 1200 divided by 5720. Okay, so that comes out to be approximately, rounded to the nearest integer, it said, it's going to be approximately 259 grams when you do this. Okay, so that's for exponential decay for this particular one. All right, so the trick to doing this is if you, whatever, how many years you have or whatever thing it has, it's out of that fraction that you want for the number of years left. All right, let's do number two together. A certain strain of bacteria, that is growing on your kitchen counter doubles every 5 minutes. Okay, so that's going to be your rate of growth. Assuming that you start with only one bacterium, how many bacteria are present at the end of 96 minutes? All right, again, it's not, 96 is not a multiple of 5. So what we have to do for this one, how many we started with is 1. We are doubling, so what's my multiplier? It's going to be 2. Okay, so out of every 5 minutes, this is going to happen. We are going to do it 96 times. So this is going to be 1 times 2 to the 96 over 5 when you do this. Technically what you're doing, you're saying 1 times 2 for 1 minute, it would be 1 out of 5. And then it would do 96 times. So that's where the 96 over 5 comes from. So if I put this in my calculator, I don't even have to put the 1 really, 2 raised to the 96 divided by 5. And we end up with 602,249. Okay, so this is 602,249. Okay, so the rate of growth or decay is the bottom number, and the number of times you want to do it is going to be the top number. Okay, I want to do one more of these. Let's take a look at number 5. The rest you're going to be doing for your homework assignment. All right, whoops, hit the wrong button, sorry. The amount of caffeine in the human body has a half-life of 6 hours. An 8-ounce cup of coffee contains approximately 95 milligrams of caffeine. If you drink the cup of coffee, how long will it take your body to reduce the amount of caffeine to 10 milligrams? Okay, so for this one, we have to actually figure out what the time is going to be. All right, so let's set up our equation first of all. Okay, so we're starting with 95 milligrams of caffeine. All right, it has a half-life, so what is our multiplier? It's going to be 0.5. All right, every 6 hours it's going to multiply. So what we don't know is how many times it's going to be out of 6 that this is going to happen. All right, so this is our general formula that we're going to have. So whatever time we have is out of 6 hours. Okay, now we want this to reduce the amount of caffeine to be 10 milligrams. So when we're done, we want this to equal 10. All right, so we're looking for t, which is an exponent, which means we have to use logs. All right, so we want to get our exponent alone but first. So divide by 95. Let me grab my calculator. 10 divided by 95 is 0.015, math enter it. I'm just going to make it a fraction a little easier. Is 2/19. Okay. All right. So this is 0.5 to the t over 6 is equal to 2/19. Okay, now I want to take the log of both sides. So this is going to be log 0.5 to the t over 6 is equal to the log of 2/19. Let me go over here. Okay, now since this is a log and this is an exponent, the exponent actually goes out front. So it's going to be t over 6 log of 0.5 equals the log of 2/19. Okay, now to solve this for t, I have to divide by the log of 0.5. So I have t over 6 is equal to the log of 2/19 divided by the log of 0.5. And then to solve this for t, I have to multiply both sides by 6. Okay, so this is what I'm going to put in my calculator. All right, so I'm going to do the log. Let me do my fraction here. The log of 2/19, log 2 divided by 19, divided by the log of 0.5. And then I'm going to take that answer multiplied by 6. Okay, so make sure you do this first, then multiply the answer by 6. And you get approximately 19.487. So it said round to the nearest integer. So this is going to be, t is going to be approximately 19 hours. Okay. All right, so that gives you an idea of how to do growth and decay when you have a different time of growth or decay that is not a multiple of what you want to do. So it's a fractional amount. What you end up with, that is your, whatever times it does is the bottom number, and the number of times it happens is the top number. Okay, so your assignment is going to be do the rest of the questions on this. You can do it in the Google form, or if you want to do it on here for practice, you can. But the answers go on the Google form.